Chapter 1, Chapter 6, Section 2, Solving Systems by Substitution. So here's the 5 steps you can go through every time. Step 1, solve for one of the variables. Step 2, substitute that expression into another equation. Step 3, solve the resulting expression. Step 4, substitute once more. And step 5, write the values from 3 and 4 as an ordered pair. What does that mean? So here in example 1, we have y equals 2x and y equals x plus 5. Well, we have y by itself in both of these equations. There's 2 ways that we can go about this. We can say y equals 2x. I'm going to use 2x just because it is simpler without the constant on the end. Y equals 2x. So whatever y equals, I can take that and substitute it from one equation into the other. So it goes down here. So when you do that, when you substitute 2x in for y, it still equals whatever's on the other side, x plus 5. And now you can solve for x. So you subtract x from both sides, and you get x equals 5. Okay? And then you take this 5, and you plug it back into one of the equations. We'll go to the simpler one. So now we have y equals 2x. So substitute that 5 in for that x. So now we have y equals 2 times 5. Y equals 10. So the answer, where these two lines meet without graphing, is an x of 5 and a y of 10. If that doesn't make as much sense to you, I can explain it one other way. And if that makes perfect sense to you, feel free to not pay attention to what I'm talking about on this next one. Since you have two things that are both equal to y, you can say that y is equal to 2x. Or I should do it separately. You can say, I'm going to make it backwards. So 2x equals y. Well, y is equal to y. And the other one is equal to x plus 5. So that's what our two y's equal. 1 equals 2x, and 1 equals x plus 5. Well, y is just the same thing as y. So 2x is equal to y, which is equal to x plus 5. But if this is equal to y, and y is equal to this, then they can be equal to each other. So you have 2x is equal to x plus 5, and from there you just solve down like we did before. It's up to you on which way you want to do it, or which way you want to think about it, whichever one is easier for you to catch on to. So then we're going to come down here to example 2. So we have y is equal to this expression. I'm going to go circle the expression that it's equal to since I don't have to do anything more with the y. And I'm going to substitute it in. So I'm going to point to where I'm taking it. So I have 2x plus y equals 5. So I'm substituting this in. So I have 2x plus, I'm going to put in parentheses what I'm substituting in because it's a complete expression. I don't have to lose anything, and sometimes you can like negatives and things. You'll see that in a little bit. So now I can say that my like terms are 2x and x. So 2x plus x is 3x. Minus 4 is equal to 5. Solving for x here, add 4. I get 3x equals 9. Divide by 3. So x is equal to 3. So now I take that and I plug it into either equation. I'm going to go ahead and plug it into the second one since it's y equals, and y is what I'm looking for. So it goes there, comes up into that x. So we get y is equal to 3 minus 4. So y equals negative 1. So we have an answer of 3, negative 1. So here in this one, we don't have a variable by itself. Instead, we're going to have to actually solve for one of our variables. You can choose either x or y. It doesn't matter which one. But I am going to, for sure, use the second equation because neither one have a coefficient greater than 1. So starting with x plus y equals 3. We're used to doing y, so we'll keep doing that. So you get y is equal to negative x plus 3. Now I know what to substitute in. So I can substitute this in for my y into the other equation. So you get x plus 4, y equals 6. That's what we're starting with. So x is equal to 4 times negative x plus 3 equals 6. We have to distribute that 4 to both things inside the parentheses. That should be x plus 4 not x equals 4. So now we get x minus 4x plus 12 equals 6. So we get negative 3x plus 12 equals 6. Subtract 12 from both sides. Now you get that negative 3x equals negative 6. Divide by your negative 3. So you get x equals 2. Take that x equals 2 and plug it in. It doesn't matter which equation you plug it into because we've used both. I'll just do the second one here. So we have x plus y equals 3. Let me 2 comes up here for x. We have 2 plus y equals 3. Subtract the 2 and we get y is equal to 1. So we get a point of 2, 1. Okay, so for our last one here, 4y minus 5x equals 9, and x minus 4y equals 11. The only one that we have that has a coefficient that's 1 is in the second equation, and that's our x. So we're going to go ahead and do that. Solving for x, so we move that 4y, so we add 4y to both sides, and we get x is equal to 4y plus 11. So now instead of substituting into an x, we're going to substitute into a y, and since we used that second equation, we'll put this into the first. So we have 4y minus 5x equals 9, taking that x and plugging it in. So we have 4y minus 5 times what we're substituting in, which is 4y plus 11. So that equals 9. That 5, negative 5, has to distribute to everything inside the parentheses since it's not dividing multiplying. So we get 4y minus 20y minus 55 is equal to 9. 4y minus 20y is going to give us negative 16y minus 55 equals 9. We're going to add 55 to both sides so that we get negative 16y is equal to 64. We divide by negative 16 on both sides, and we get that y is equal to a negative 4. Take that negative 4 and plug it in. So since we have y, we can just plug it in to this one, which we solve for, just since we're looking for x. So x is equal to 4y plus 11. So y is negative 4, goes in there. Get x is equal to 4 times negative 4 plus 11. So we get x is equal to negative 16 plus 11, or x equals negative 5. So we have a point of negative 5, negative 4. Your homework is in the packet.